Hello and welcome to the Easy Sleep Science channel. Tonight, let yourself drift into the ever-changing world of weather, the endless dance between sky and storm, where air, light, and water weave together around us each day. The sky may seem calm, but it's full of chaos and wonder. It's a living ocean of air, rippling with winds, painting clouds, and stirred by invisible currents of heat. Within that delicate web, sunlight scatters into colors, lightning tears open the heavens with white fire, and storms are born and cross entire oceans. Weather is not just the planet's mood, it is its breath, its heartbeat, and the endless music of Earth. If you enjoy gentle scientific journeys like this, please like and subscribe or share your favorite fact in the comments. It helps other restless souls find this place one by one. Now you don't need to do anything, just rest, breathe deeply, and let your mind wander into the wondrous world of weather. A single cloud can weigh more than 1,000,000 elephants. When you look up at a drifting cloud, it seems soft and weightless. But the truth is astonishing. A typical cumulus cloud, like those in summer skies, can contain hundreds of thousands of tons of water. Each droplet is so tiny, it's invisible to the naked eye. Yet together, they form a massive body heavier than 1,000,000 elephants standing side by side. And still the cloud floats because the water is divided into countless microdroplets, each lifted by rising warm air. How amazing that something so immense and heavy can appear so light and delicate. Next time you look up, remember that gentle cloud is carrying the weight of a lake. Lightning is hotter than the surface of the sun. In a flash, it splits the sky with white fire temperatures soaring past 30,000 degrees Celsius, several times hotter than the sun's surface. That energy is so intense that it turns air into glowing plasma. The sudden expansion of that superheated air creates the sound we hear, thunder, rolling across the sky. Each lightning bolt is a natural experiment, compressing unimaginable heat and energy into a single millisecond. Some bolts stretch for miles, linking sky and earth in shimmering light. Though fierce lightning brings life, it helps fix nitrogen into soil, feeding plants, and in turn feeding us. Thunder is the air exploding from heat. Its deep rumble, sometimes distant like drums, sometimes sharp and cracking, is the voice of lightning itself. When lightning strikes, it heats the air so fast that the molecules can't expand quickly enough, producing shock waves that travel faster than sound. That's thunder. Depending on the distance, the sound may boom, roll, or echo through hills and homes. Because light travels faster than sound, we always see lightning before we hear thunder. By counting the seconds between them, you can estimate how far the storm is. Thunder is both a warning and a reminder above us. Colossal natural forces are still at play, beating the deep rhythm of the storm. Raindrops are not shaped like teardrops. Children often draw them pointed on top and round below, but in truth, they're not shaped that way. The smallest drops are nearly perfect spheres due to surface tension. As they grow larger, air resistance flattens their bottoms, making them look more like tiny hamburger buns than teardrops. If they get too big, they break apart into smaller drops. Each raindrop falls with its own perfect shape, soft, round, and consistent, as if carved by nature. The teardrop shape is just an illusion we see when water slides down glass or skin stretched by gravity. The real raindrops that fall on roofs, meadows, and rivers are tiny gems, not sharp, not pointed, just pure and gentle. The smell of rain comes from ancient oils and cosmic dust. There's even a word for that scent, petrichor. It's created by a mix of wonders, small plants releasing oils into dry soil during droughts, which raindrops later lift into the air. At the same time, soil bacteria produce a compound called geosmin, giving that rich, earthy aroma. During storms, lightning splits oxygen and nitrogen to form ozone, adding a fresh, clean note. Together, they become the fragrance of rain, the scent of ancient earth, of life, and of the sky itself. Every breath you take is a piece of Earth's long story. Snowflakes can fall at very different speeds. We often imagine them drifting slowly, but some fall surprisingly fast, depending on their size and shape. Tiny crystals float softly, while large clustered flakes can fall several meters per second. Wind spins and lifts them, making each flake's path a dance between gravity, air, and ice geometry. Some grow wider than a coin. Under perfect conditions, humid air, gentle wind, steady cold, they can merge into flakes as wide as a small plate. The largest snowflake ever recorded in Montana in the 19th century was over 15 inches across. Imagine those enormous icy feathers drifting down slowly, glimmering in still air. A blizzard can make you unable to see your own hand. A blizzard isn't just heavy snow. It's when snow and wind blend into a blinding white wall. In its heart, visibility can drop to only a few meters. Winds whip frozen snow so fiercely that direction itself disappears. Temperatures plunge, and wind chill can burn skin in minutes. On open plains or mountain peaks, blizzards are true hazards. Yet within their fury lies a strange beauty, a world turned white and silent where chaos and calm coexist. Hailstones form in perfect layers like onions. Inside thunderclouds, droplets are hurled upward into freezing zones, then fall and rise again, each cycle adding a new layer of ice. When they finally fall, the hailstones reveal concentric rings like wood grain, a frozen record of the storm that made them. Small ones are harmless, but large ones can shatter glass, crush crops, or weigh more than a pound. They're natural sculptures, memories of a storm in icy form. The largest hailstone ever recorded fell in South Dakota in 2010, weighing nearly a kilogram, still holding the record today. A tornado can drive a straw through solid wood. Tornadoes are among nature's most astonishing phenomena, air twisting with extraordinary power. It sounds like a myth, but it's real. Pieces of straw have been found embedded deep inside wooden beams. Within a tornado, objects are hurled at incredible speed, turning soft grass into piercing darts. Straw, leaves, and even blades of grass have been discovered stuck in walls after storms. Air, when spun into a vortex, needs no weapon. It becomes one. Winds in the strongest EF5 tornadoes can exceed 480 km/h, fast enough to lift cars, bend steel, and tear buildings apart. Their sound is often compared to a roaring freight train, raw, violent, unstoppable. Each tornado is the atmosphere's most focused burst of energy, a reminder that the air around us can move with unimaginable strength. Tropical cyclones release more energy than all of humanity's power plants combined. A massive storm can span hundreds of miles, drawing warmth and moisture from the ocean, then unleashing staggering amounts of energy. In a single day, a hurricane produces more power than all the electricity generated on Earth. Most of that energy is heat released as billions of droplets condense. The rest becomes roaring winds and crashing waves. From space, a storm is the most spectacular weather machine on the planet. And yet the calmest part lies at its wildest center, the eye. Step inside and the wind and rain suddenly stop. The sky opens and sometimes sunlight breaks through. But it's not a safe place. Around the eye lies the eye wall, where winds reach their peak. The eye is the storm's still heart, peaceful only because chaos surrounds it. Those who have stood in that eerie calm describe it as both beautiful and terrifying, knowing the storm will soon return. Monsoons can transform an entire region in a single season. In many places, life is tied to the rhythm of the monsoon. The land stays parched for months. Then suddenly the sky opens and rain pours down. Rivers rise, fields flood, forests turn green again. Monsoon rains both sustain hundreds of millions of people and can also cause floods and landslides. In India, Southeast Asia, and parts of Africa, whole cultures revolve around that cycle. Farmers sow to the cadence of the rains. Festivals welcome the first downpour of the season. The monsoon is the breath of a continent, the rhythm of life written in water, wind, and time. The Atacama Desert can go decades without a single drop of rain. Located in northern Chile, it's the driest place on Earth outside the polar regions. Some weather stations have never recorded rain. The soil is so barren that NASA uses it to simulate Martian conditions. And yet even here, life hangs on plants, drink moisture from fog, microorganisms live hidden beneath the ground. On the rare occasions when rain does fall, the desert bursts into bloom, the desierto florido. In Atacama, every drop of water is a miracle. The wettest place on Earth is drowned in walls of rain. In northeastern India lies the village of Mausanram, the rainiest spot on the planet. Each year, monsoon winds from the Bay of Bengal strike the mountains, lifting moist air high and dumping nearly 12 meters of rain. The deluge is so constant that waterfalls pour everywhere, rivers overflow roads, and the sound of water becomes the background of life. People build sturdy roofs and use living root bridges to cross streams. Here, rain is more than weather. It is a way of life, the heartbeat of the land. In contrast, some places thirst endlessly. Weather is not shared evenly. One place is awash, another aches for water. The hottest air temperatures ever recorded can melt car tires. In July 1913 in Death Valley, California, furnace-hot winds blew through and the temperature reached 56.7 degrees C, Earth's record. At that level, asphalt softens, metal sears, and tires can go mushy. The human body can scarcely endure it without water. Though Kuwait and Iran have come close, Death Valley still holds the record. That heat reminds us the atmosphere isn't always gentle. At times, it becomes a brutal kiln. The coldest air on Earth can freeze metal solid in seconds. On the Antarctic plateau, far from the sea, the Vostok station recorded 89.2 degrees in 1983, colder than dry ice, cold enough to make steel brittle and shatter glass. Recent satellite measurements have found spots near 98 degrees C, the outer limit of cold on our blue planet. In such conditions, breath crystallizes machinery, locks up, and exposed skin can freeze almost instantly. The temperature is even colder than the average surface temperature of Mars. Living here demands extraordinary preparation, heated shelter, insulated gear, and constant vigilance. And yet right in Earth's icy heart, weather still moves, winds howl, snow drifts, pile up, and clouds creep slowly overhead. This is the far frontier of cold, where Earth's atmosphere brushes against its own extreme stillness. Prolonged heat kills more people than any other form of extreme weather. Storms and floods make the front page for their visual power. But the deadliest weather is quieter heat waves, when the air stands still and temperatures soar for days or weeks. The human body begins to fail. Without relief, heat stress builds, strains the heart, and dries out tissues. Cities suffer most where asphalt and concrete absorb heat, creating suffocating islands. Night brings scarcely any rest as buildings release the day's stored heat. Across the world, heat waves have claimed tens of thousands of lives, often silently striking hardest at the elderly, children, and those without shelter. Unlike a hurricane, you may not see its destruction, but it shows up in rising hospitalizations, in withered fields, and in rivers too warm for fish where die-offs spread. A heat wave is the weather's most insidious threat. It slips in quietly, yet devastates. Fog can be so thick that you can't see your own feet. Fog is one of weather's gentlest illusions, a cloud dropped to the ground, wrapping the world in pale stillness. It often erases the horizon, blurring houses and trees into ghostly silhouettes. In rare cases, fog can grow so dense that visibility shrinks to a few steps, and people inside it say they can't even see their own feet. In this kind of fog, sound turns strange, muffled, and close, as if the air itself has thickened. Planes or grounded ships creep along, and drivers inch forward in wary awe. Soft as it is, fog can be among the most dangerous phenomena, and walking inside it can feel like another world, like moving through a dream where reality's edges dissolve, leaving only whiteness and the sound of your own breath. Dew can gather enough water to sustain life in the desert. In the dry hush of the desert, rain is rare, but dew is a quiet savior. After sunset, the ground cools rapidly. If the air temperature dips below a certain point, moisture condenses on rocks, leaves, and even the tiniest grains of sand. Each morning, the desert wakes adorned with fine droplets. For plants and animals evolved for this place, dew can be the line between life and death. Beetles tilt their bodies to funnel droplets to their mouths. Some plants guide dew down their stems to thirsty roots. Humans have learned to harvest dew with mesh or special surfaces, gathering those glittering beads of water. Though each drop is small together, they become sustenance, where rain may be absent for months. Dew is the desert's rain, arriving in whispers instead of storms. Frost crystals can grow into spiky forests of ice. On winter mornings, frost sometimes paints windows with intricate patterns, curling leaves, ferny tendrils, lace that sparkles. These are ice crystals formed when water vapor freezes directly onto a cold surface. But under the right conditions, frost can grow larger and far stranger. On mountaintops and polar plateaus, frost can form forests of ice spines called hoarfrost. Their crystals rise into jagged spires, sometimes inches long, catching the first light like glasswork. Each spike grows as vapor keeps depositing on its surface layer upon layer until the landscape bristles with icy blades. In the stillness of cold air, they are fragile, pristine, and sharp. A single touch can shatter them. While they last, they turn the ordinary world into a realm of wonder, a forest of ice born from nothing but cold air and breath. Freezing rain can sheath a city in a dangerous layer of glass. Its beauty carries a blade. When rain falls through a band of sub-freezing air near the ground, the droplets become super-cooled, still liquid as they fall, but ready to freeze on contact. Roads glaze with invisible ice. Tree branches become crystal sculptures. Power lines sag under unexpected weight. At night, headlights strike a world locked in place, exploding into 1,000 reflections. Beneath the glitter lies danger roads, nearly impassable trees, snapping whole neighborhoods without power for days. To step outside in freezing rain is to walk through a jeweled but treacherous world where every surface is slick and perilous. It is weather at its most deceptive, breathtakingly beautiful, yet hazardous. Dust devils can tower higher than skyscrapers. On a hot, dry afternoon, uneven heating of the ground sends columns of warm air spiraling upward. Sometimes they begin to spin, forming dust devils. Many are small, only a few meters across, but some can stretch astonishingly tall, twisting towers of dust higher than skyscrapers. Unlike tornadoes, dust devils form under clear skies, dancing over deserts, fields, and even parking lots. Small ones only toss leaves and sand, but larger columns can topple fences, lift roofs, or hurl debris skimming along the ground. Pilots have reported seeing colossal dust devils from the air looming like temporary giants. They are brief, chaotic, and mesmerizing tiny whirlwinds, revealing the atmosphere's vitality even on days that seem still. To watch a dust devil is to see invisible heat currents and air suddenly made visible in dramatic form. Waterspouts can spiral over the ocean like liquid tornadoes. Imagine standing on the shore and seeing a slender, twisting column rise from the sea to the clouds. That's a waterspout, a vortex of air and mist akin to a tornado, but formed over water. Some are relatively weak, spinning harmlessly across bays or lakes before fading. Others are strong enough to toss boats, snap masts, and whip waves into fury. Fishermen have long told of waterspouts appearing like ghostly funnels on the horizon. From afar, they can be strangely beautiful, silver spirals, skimming the sea lit by sun or flashes of lightning. Up close, they are raw force blending storm winds with ocean mist. Waterspouts remind us that tornado-like fury isn't confined to land. Even a calm sea can suddenly twist itself into a tower of spinning water reaching for the sky. Microbursts can slam airplanes out of the sky. Microbursts are one of the weather's dangerous, hard-to-see threats. They occur when a thunderstorm suddenly drops a massive pool of cool air that plunges to the ground and then blasts outward at high speed. To people on the ground, a microburst feels like a sudden violent gust that can topple trees or flatten crops. For aircraft, the danger is greater. Flying into a microburst, a plane can abruptly lose lift, forced downward faster than a pilot can recover. Several past accidents revealed their deadliness, prompting new safety systems to detect them. Microbursts are often brief, sometimes lasting only minutes, but they are ferocious with winds that can exceed 100 mph. Invisible until they strike, they prove that thunderstorms don't just bring lightning and rain, they can unleash sudden, devastating punches of air. Supercells can grow larger than an entire state. Most thunderstorms are small local events lasting less than an hour. Supercells are different, large, organized storms with rotating updrafts that can persist for many hours. On satellite images, they can stretch for hundreds of miles, sometimes larger than a U.S. state. Inside those towering clouds, more than 10 miles high, a whole miniature weather system churns, lightning flashing thousands of times per minute, hail layering ice ring upon ring, and tornadoes forming glittering behind sheets of rain. Supercells are rare, but they are the engines of the planet's most destructive weather. Seen from afar as they form, you can almost watch the atmosphere brace itself, a rolling black wall of clouds so vast it redraws the horizon. These are storms that seem alive, breathing, rotating and growing, shrinking the land beneath them. Some thunderstorm systems can last more than 12 hours. We often think of a storm as brief, a burst of lightning, a wave of rain, then clearing skies. But under the right conditions, storms can endure. Systems called mesoscale convective complexes can last 12 hours or longer, sweeping across broad regions while maintaining strength. Inside, bursts of storms rise and collapse in self-sustaining cycles, fueled by warm, moist air and dropping torrents of rain. These long-lived storms can cause widespread flooding, relentless lightning, and strong winds. From above, they appear as vast, glowing domes lit by flickering lightning like a living organism. For people below, the storm becomes a companion. Through the night, the endless rumble, the repeated flashes, the rain that seems without end. They remind us that weather isn't always a fleeting moment. Sometimes the sky decides to stay long and restless. There is a storm in Venezuela that has produced lightning for centuries at the mouth of the Catatumbo River, a storm that has thundered for centuries. Called Catatumbo lightning. It's a natural phenomenon where thunderstorms occur almost nightly, sometimes for 10 hours more than 200 nights a year. Unique geography. Warm Caribbean winds colliding with cold Andean air creates the perfect recipe for an unending storm. From miles away, the sky over Lake Maracaibo glows with endless flashes, a silent fireworks show visible even to sailors far offshore. For generations, people have called it the Lighthouse of Maracaibo, a beacon that seems eternal. Scientists are still studying why this place is so special for storms. But one thing is certain. Nowhere else on Earth does lightning beat with such a persistent, timeless rhythm. Weather balloons can fly higher than Mount Everest. Every day, hundreds of weather balloons are launched worldwide, carrying instruments called radiosondes into the sky. They look simple, large balloons filled with helium or hydrogen, but they climb to astonishing heights. Rising at about 1,000 feet per minute, they drift above airplanes, above clouds into the stratosphere. By the time they burst, they can be more than 20 miles high, higher than Everest. At that altitude, the air is so thin and cold that temperatures can plunge to 90 degrees, and the horizon curves against the black of space. As they rise, these balloons measure temperature, pressure, humidity, and wind, transmitting data that lets us forecast the weather days in advance. Though few ever see them, they are explorers of the atmosphere, quiet travelers mapping the invisible ocean of air around the planet. Satellites can watch tropical cyclones from space in real time. Orbiting hundreds of miles above Earth, satellites keep watch like silent night guards. When a storm forms over the ocean, a satellite catches its spiraling arms, stretching for hundreds of miles with an eye opening like a giant pupil looking upward. From space, a storm is breathtakingly beautiful, an endless geometry of curling clouds. Within those graceful lines lies destructive power. Modern satellites can track storms in real time, map rainfall, measure wind speed, and even peer inside with infrared to see the heat signatures of clouds. That constant vigilance saves lives, giving coastal cities precious hours or days to prepare. Before satellite storms, often struck with very little warning, now we can follow them as they grow, move, and finally fade back into the sea. From the cold stillness of orbit, satellites see Earth's fiercest storms not as chaos, but as mesmerizing living patterns. Doppler radar can track raindrops moving through the air. As a storm approaches, those familiar green and red patches on the weather map come from radar. But modern Doppler radar does more than see rain. By sending radio waves into raindrops and snowflakes, it not only finds their location, but also measures their speed and direction. That lets meteorologists look inside a storm with remarkable detail, track rotating regions that can spawn tornadoes or spot heavy rain bands likely to cause flooding. In essence, Doppler radar turns the atmosphere's invisible motion into visible maps, a portrait of swirling chaos translated into color. Every red, blue, or purple pixel stands for countless droplets tumbling through the sky. To those who can read it, a Doppler image is a storm's fingerprint revealing its hidden structure and showing us the choreography of weather unfolding overhead. Auroras are a kind of space weather. High over the polar regions, shimmering curtains of green, purple, and red dance across the night sky. That is the northern lights, the aurora borealis. Though it looks like earthly weather, its origin is cosmic. Streams of charged particles from the sun strike Earth's magnetic field and are guided toward the poles. When they collide with atoms in the upper atmosphere, they excite them and make them glow. The ribbons of moving light we see are the atmosphere coming alive. This is space weather, a reminder that the air around us is a shield against the sun's endless energy. Watching the aurora is like seeing Earth's magnetic heartbeat, a direct thread between solar storms and the thin veil of gas that protects our world. Solar storms can disturb Earth's weather systems. When the sun erupts, clouds of plasma and magnetic energy sweep through space at astonishing speeds. They can reach Earth in just a few days, jostling our magnetic field and lighting the auroras brilliantly. They can also go further, disrupting satellites and power grids and even nudging atmospheric circulation. Some scientists believe strong solar storms can temporarily influence the weather by altering how the atmosphere absorbs energy. These links are subtle and not yet fully understood, but they remind us that Earth's weather is not separate from space. We live within the sun's extended reach, and our atmosphere is always being stirred by its invisible hand. Even under clear skies, solar storms ripple through our environment's structure. In that sense, Earth's weather never fully belongs to itself. It is part of a larger conversation with the star that sustains us. Even airplane contrails can change local clouds. On a clear day, you may see thin, straight lines slicing across the sky behind aircraft. These condensation trails, formed when exhaust mixes with cold, moist air, can persist and spread into wispy cloud sheets. Delicate as they look, they can alter local weather by changing how sunlight and heat move through the atmosphere. In some regions, dense flight traffic is thought to significantly increase cloud cover, quietly warming nights and cooling days. After the September 11, 2001 flight shutdown in the United States, scientists observed unusual swings between daytime and nighttime temperatures, hinting at the daily influence of contrails on the energy balance. It is a reminder that even small traces of human activity can ripple across the ocean of weather, painting the sky and shifting the planet's breath in ways we rarely notice. Flash floods can shove boulders the size of cars. Water is usually gentle carving valleys over centuries and wearing mountains down one grain at a time. In a flash flood, water shows another face, sudden, furious, unstoppable. When rain dumps in a short time, rivers can rise in minutes, and dry washes can turn into roaring torrents. Those walls of water carry sand, branches, and even multi-ton boulders. Cars can be lifted and swept away. Streets become rivers, bridges fail, and landscapes are rearranged overnight. Flash floods are especially dangerous because they strike with almost no warning often, while skies upstream still look calm. For those caught in their path, the power of moving water is unforgettable, the voice of gravity amplified by storms reminding us that weather can turn the softest element into one of Earth's most destructive forces. Some droughts last for centuries. When the rains do not come, the world changes slowly but profoundly. Crops wither, streams shrink, and the land cracks. Most droughts last months or years, but in geologic history there have been ones that persisted for centuries. These mega-droughts leave their marks in tree rings, lake sediments, and the remnants of vanished civilizations. In North America, evidence shows the western United States endured centuries-long droughts in the medieval period, far longer than what is seen today. Droughts like those reshape entire regions, turning forests into grasslands and grasslands into desert. People are forced to migrate, abandon settlements, or adapt in extraordinary ways. Drought is a quiet kind of weather. No storms, no thunder, no spectacle, only absence stretched so long that landscapes and history bend to it. In that quiet way, drought can be as powerful as a hurricane or a flood. El Niño can shake the weather across the entire planet. Every few years, the Pacific warms in an event called El Niño. When it does, the atmosphere responds. Winds shift, currents change, and weather patterns ripple globally. Parts of South America are drenched, while parts of Asia go dry. Tropical cyclones, monsoons, and even winter storms in North America can be steered by El Niño's rhythm. What begins as a change in ocean temperature near the equator ends up affecting regions thousands of miles away. It is a vivid proof of Earth's interconnected systems. Ocean and atmosphere move in step, touching weather on every continent. For farmers, fishers, and scientists, El Niño is both a challenge and a mystery, a reminder that the planet's climate heartbeat is set not by a single place, but by vast currents beneath the sky. La Niña brings the opposite effects of a cool wind. After El Niño often comes its counterpart, La Niña. In these periods, the Pacific surface cools and the winds over it strengthen. The impacts are global but reversed. Places that were wet can turn dry. Tropical cyclones can form in different basins. Winters in some parts of the world become harsher. La Niña is part of a natural cycle, a pendulum swinging between warm and cool at the equatorial Pacific, and its echoes ring through the entire atmosphere. Though invisible to the naked eye, these shifts are strong enough to change rainfall in Africa, tropical storms in Asia, and storm tracks across North America. The idea that cooling seawater in one place can steer weather thousands of miles away reveals the planet's deep connections, a world where weather is truly one system. Ocean currents run like giant rivers of heat. Beneath the surface, vast, persistent flows move like hidden rivers. Unlike freshwater streams, they are driven by temperature winds and Earth's rotation. They carry enormous amounts of heat around the globe, redistributing the sun's energy and balancing the climate. Warm water moves from the equator toward the poles, while cold water sinks and slides back toward the tropics. Without these invisible rivers, much of Earth would be uninhabitable, the equator stifling and the mid-latitudes frozen. Instead, the currents act as Earth's hidden thermostat, softening extremes. From space, the eddies they spin look like living art big enough to blanket entire seas. Standing on a shore and feeling a warm flow slip past your ankles, you are touching the edge of a system that connects continents and endless circulation, linking every kind of weather. The Gulf Stream helps keep Europe mild in winter. Europe lies far to the north, sharing latitudes with Canada, yet its winters are much gentler. The reason flows across the Atlantic, the Gulf Stream. This powerful current carries warm water from the Gulf of Mexico northeastward, releasing heat to the air as it goes. By the time it reaches Europe, the air above it is warmer than it otherwise would be, easing winter's bite. Without the Gulf Stream, much of northern Europe would feel more like Siberia, with harsher winters and shorter growing seasons. Agriculture, cities, and even culture have been shaped by that steady, warm river. Scientists keep close watch on it because changes in the Gulf Stream can have far-reaching global effects. For now, it remains one of Earth's vital lifelines, a conveyor of heat and a quiet partner in the dance of weather and climate. The polar vortex can shove Arctic cold far south. High over the Arctic spins a mass of frigid air called the polar vortex. Normally, this circulation is pinned in place aloft by strong winds. Sometimes it weakens and wobbles, letting Arctic cold spill south. When that happens, regions far from the pole like the U.S. Midwest or Central Europe can suddenly plunge into extreme cold, with temperatures dropping to dangerous levels. Cold air outbreaks can freeze rivers, paralyze cities, and shatter records. The phrase polar vortex is familiar from newscasts, but the phenomenon itself is not new. It's part of Earth's natural atmospheric rhythm, a reminder that the Arctic isn't isolated. It's connected to all of us. Next time icy air suddenly sweeps through your city, it may be the edge of that colossal crown of spinning cold. Volcanic eruptions can alter global weather. When a volcano erupts explosively, its effects reach far beyond the mountain. Ash and gases are hurled into the stratosphere, where winds disperse them around the world. Tiny sulfur dioxide particles can linger for months, even years, reflecting sunlight and cooling the planet. The 1815 Tambora eruption created the year without a summer, bringing frost and famine across the northern hemisphere. Crops failed, rivers froze in midsummer, and skies turned dim with ash. More recently, Pinatubo in 1991 cooled global temperatures for several years. Volcanoes are a sharp reminder of Earth's tightly bound systems. The fury of one mountain can tilt the balance of light and air worldwide. In the world of weather, even Earth's inner fire has a voice whispering through clouds and storms. Wildfires can create their own lightning. In extreme fires, flames can tower hundreds of feet high. Immense heat drives powerful updrafts, lofting ash and smoke skyward. Within those clouds, particles collide and charge, just like in a thunderstorm. The result is pyrocumulus thunderclouds born of fire that can strike lightning back into the burning forest. These bolts can ignite new blazes, creating a loop of fire feeding on itself. Firefighters sometimes witness the sky flashing with lightning, while the inferno roars below, a haunting fusion of flame and storm. This shows that weather doesn't only act upon the landscape can generate weather of its own. A burning forest can become a temporary weather system alive with thunder and fire, a fierce reminder of nature's ability to amplify itself in extraordinary ways. Wildfire smoke can seed strange clouds. When massive fires shoot columns of smoke high into the sky, they do more than darken the horizon. The fine particles in smoke can act as condensation nuclei for water vapor forming clouds. Sometimes these clouds grow thick enough to cast broad shadows over the ground, changing temperatures below. In extreme cases, smoke-driven clouds can climb into the stratosphere and travel thousands of miles. There they can linger for weeks, subtly shifting weather far from the original fire. The sight is eerie clouds, tinted orange or gray, glowing red in sunlight. Pilots have reported flying through smoke so dense it felt like perpetual dusk at noon. These clouds aren't born of sea or sky, but of the land's own flames. Proof that fire and weather interweave, each can shape the other in unexpected ways. Dust from the Sahara can ride the wind all the way to the Amazon. Each year, winds lift millions of tons of fine dust from the Sahara and carry it high into the atmosphere. These plumes cross the Atlantic, visible on satellite images, as a golden veil stretching for thousands of miles. In the end, much of the dust falls over the Amazon rainforest, bringing essential nutrients, especially phosphorus, that enrich the soil. Without this transoceanic journey, parts of the Amazon might struggle to maintain their astonishing biodiversity. That one of the world's driest places feeds one of the wettest and lushest is a powerful reminder of the planet's interconnection. Even the air is a conveyor belt linking desert and rainforest in an invisible exchange. When you breathe air that has brushed far-off lands, you may be inhaling fine dust from ancient dunes lofted across an ocean to nourish life on the other side of the world. Tropical cyclones can stir the sea into glowing fields of planktonic light. Storms are famous for destructive wind and rain, but beneath the waves they awaken another wonder. When a massive storm churns the ocean, it jolts plankton, microscopic organisms that sometimes glow when disturbed. Sailors have told of sailing through seas that shimmered ghostly blue during a storm, as if the water were alive. This bioluminescence is a chemical response inside the plankton, a defensive mechanism triggered by turbulence. Though satellites can't see it, those who have witnessed it rarely forget a storm not only roars in the sky, it paints light beneath the sea. These glowing oceans remind us that weather touches every layer of the planet. From the atmosphere to the deep sea floor, even amid destruction, storms create strange beauty, as life answers the violence of wind and waves with sparks of living light. Weather helps carve mountains into valleys. Mountains seem eternal, but weather quietly reshapes them. Rain seeps into cracks, freezes and thaws, prying rocks apart. Wind scours exposed faces, carrying grains away. Rivers cut mountain flanks, chiseling valleys and deep canyons. Over millions of years, even the mightiest peaks are worn down, sharp edges round summits sink. The Himalaya and Rockies still rise under tectonic forces, yet weather pushes back with tireless patience. Every landslide, every falling boulder, every rushing stream is the atmosphere's silent chisel. Without erosion, Earth would be harsher and more jagged. Weather has sculpted gentle hills, fertile valleys, and meandering rivers. Wind can sculpt rock into arches and spires. Across the world's deserts, strange shapes rise from the ground, arches, spires, and mushroom rocks that look otherworldly, the wind's handiwork. Carrying sand like a natural sandblaster, the wind etches stone over centuries, wearing away softer layers and leaving the harder ones. In some places, stone columns stab the sky. In others, perfect arches frame it. Monument Valley, Utah's arches and the Sahara's pinnacles are all products of that patient work. A breeze on your skin may feel gentle, but given time, it sculpts landscapes worthy of a gallery, chiseled not by tools, but by invisible currents, pushing grains across rock. Lightning can turn sand into glass. When lightning strikes sandy ground, its intense heat melts quartz grains into glass. The strike fuses the sand into hollow branching structures called fulgurites, lightning petrified. These fragile tubes can extend several feet underground their surfaces, glossy and rippled by melted minerals. Each one is a record of a single bolt of fiery signature burned into earth. Fulgurites are prized by collectors and geologists, natural sculptures born in a heartbeat of violent energy. Holding a piece is like holding a fossil of lightning proof that the sky can remake stone in an instant. Glaciers flow like rivers of ice, reshaping continents. To the eye, glaciers seem still, but they are always moving from centimeters to meters per day. Over centuries, that slow, steady motion sculpts the land on a grand scale, grinding mountains into U-shaped valleys, dragging boulders for miles, polishing rock into smooth plains. During the last ice age, ice covered much of North America and Europe, reshaping entire continents as it advanced and retreated. Today, remnants persist in Greenland, Antarctica, and high mountain ranges, still molding the terrain. Stand near a glacier, and you feel the weight of time, a river not of water, but of solid ice flowing with quiet persistence. Glaciers are living landscapes, slow, unstoppable, always changing, whispering of ancient winters and the power of weather frozen into motion. Avalanches can move faster than highway traffic. High in snowy mountains, a delicate balance holds between slope and snowpack. When that balance breaks, an avalanche begins. A small slide accelerates, gathering snow ice and debris into a thundering flow. Speeds can exceed 80 mph, faster than cars on the freeway, with crushing force enough to sweep away forests, houses, and roads. Its sound is like rolling thunder pouring down a mountainside. Once unleashed, it cannot be stopped. For skiers and climbers, avalanches are a constant hazard, triggered by weather loading or a single step. They are also part of the mountain's natural cycle, redistributing snow-shaping slopes and feeding valleys below. To watch one from a safe distance is to witness nature's sudden fury, a reminder that snow isn't always gentle. It can become a devastating flood in an instant. Icebergs hide nearly 90% of their mass underwater. The tip of the iceberg comes from a striking truth. Most of what we see is only a small fraction of what lies beneath. When chunks break off glaciers or ice shelves and drift at sea, the majority of their volume sits below the surface, often just about 10% shows above. That invisibility makes icebergs hazardous to ships. The Titanic tragedy is proof. Some are small, others are colossal, taller than skyscrapers and miles long. As they drift, they release fresh water into the ocean, quietly nudging currents and ecosystems. To imagine a giant block moving silently, mostly unseen, sparks the mind. Icebergs are monuments of frozen time, slowly dissolving into the sea, their true size known mostly to the deep ocean itself. Permafrost locks away ancient life. In the frozen soils of the Arctic and Siberia lies permafrost ground that has remained frozen for thousands of years. Trapped within are seeds, microbes, and even remains of extinct creatures like mammoths. As long as permafrost stays frozen, these relics are preserved as if sealed in Earth's freezer. But when it thaws, ancient secrets awaken. Scientists have revived seeds tens of thousands of years old and even microorganisms that slept for millennia. Thawing permafrost also releases methane and carbon dioxide gases that can affect the global climate. Cold snaps can freeze rivers, paralyze cities, and break records. The phrase polar vortex is familiar from the news, but this phenomenon is not new. It is part of Earth's natural atmospheric rhythm, a reminder that the Arctic is not separate but connected to all of us. Next time icy air suddenly sweeps through your city, it may be the edge of that gigantic crown of spinning cold. Volcanic eruptions can change global weather. When a volcano explodes violently, its effects reach far beyond the mountain. Eruptions blast ash and gases into the stratosphere, where winds spread them around the world. Tiny sulfur dioxide particles can linger for months or even years, reflecting sunlight and cooling the planet. The 1815 Tambora eruption created the year without a summer, bringing frost and famine across the northern hemisphere. Crops failed, rivers froze in midsummer, and skies were dim with ash. More recently, Pinatubo in 1991 lowered global temperatures for a few years. Volcanoes are a sharp reminder of how tightly Earth's systems are linked. The fury of one mountain can throw off the balance of light and air worldwide. In the realm of weather, even Earth's inner fire has a voice whispering through clouds and storms. Wildfires can generate their own lightning. In extreme fires, flames can reach hundreds of feet high. Enormous heat forces the air to surge upward, lifting ash and smoke into the sky. Inside those clouds, particles collide and become charged, just as in a thunderstorm. The result is pyrocumulus thunderclouds born of fire that can lash lightning back into the burning forest. These bolts can ignite new blazes, creating a loop of fire feeding on itself. Firefighters sometimes witness the sky flickering with lightning while flames roar below, a chilling fusion of fire and storm. This shows that weather is not only a force acting on the landscape, but it can also be created by the landscape itself. A burning forest can become a temporary weather system, alive with thunder and flame, a fierce reminder of nature's ability to amplify itself in extraordinary ways. Smoke from wildfires can seed strange clouds. When massive wildfires launch towering smoke columns, they do more than darken the horizon. The tiny particles in smoke can act as condensation nuclei that water vapor clings to, forming clouds. Sometimes these clouds grow thick enough to cast broad shadows, changing temperatures below. In extreme cases, smoke-driven clouds can climb into the stratosphere and travel thousands of miles. There they can linger for weeks, quietly nudging weather far from the original fire. The sight is haunting clouds, with unusual hues of orange and gray glowing red in sunlight. Pilots have reported flying through smoke so dense it felt like twilight at noon. These clouds are born not of sea or sky, but of the land's own flames. They are evidence that fire and weather interlace, each able to create and shape the other in unexpected ways. Dust from the Sahara can ride the wind all the way to the Amazon. Each year, winds lift millions of tons of fine Saharan dust into the air. These plumes cross the Atlantic, sometimes visible on satellite images as a golden veil stretching for thousands of miles. Eventually, much of the dust falls over the Amazon rainforest, carrying essential nutrients, especially phosphorus, that enrich the soil. Without this transoceanic journey, some parts of the Amazon might struggle to sustain its astonishing biodiversity. The idea that one of the driest places feeds one of the wettest and lushest is a powerful reminder of the planet's interconnectedness. Even the air is a conveyor belt linking desert and rainforest in an invisible exchange. When you breathe air that has touched distant lands, you may be inhaling fine dust from ancient dunes carried across the ocean to nourish life on the other side of the world. Tropical cyclones can churn the sea into glowing fields of plankton. Storms are notorious for destructive wind and rain, but beneath the waves, they stir up another wonder. When a massive storm churns the ocean, it agitates plankton, microscopic organisms that sometimes glow when disturbed. Sailors have told of passing through waters that shone an eerie blue during a storm, as if the sea were alive. This bioluminescence is a chemical response inside the plankton, a defensive mechanism triggered by turbulence. Although satellites cannot see it, those who have witnessed it rarely forget a storm that roars in the sky while painting light beneath the sea. These shining oceans remind us that weather touches every layer of the planet, from the atmosphere to the deep sea floor. Even amid destruction, storms create strange beauty, as life answers the violence of wind and waves with sparks of living light. Weather helps chisel mountains into valleys. Mountains seem eternal, but weather patiently reshapes them. Rain seeps into cracks, freezes and thaws, prying rock apart. Wind scours exposed faces, carrying away grains. Rivers carve into mountain flanks, cutting valleys and deep gorges. Over millions of years, even the mightiest peaks are worn down. Sharp edges are rounded off, and summits are lower. The Himalaya and Rockies still rise under tectonic forces, yet weather pushes back with tireless patience. Every landslide, every falling boulder, every rushing stream is the atmosphere's silent chisel. Without erosion, Earth would be far rougher and harsher. Weather has sculpted gentle hills, fertile valleys, and meandering rivers. Wind can sculpt rock into arches and spires. Across the world's deserts, strange forms rise from the ground: arches, spires, and mushroom rocks that seem otherworldly, the wind's handiwork. Carrying sand like a natural sandblaster, the wind etches rock over centuries, wearing away softer layers and leaving the harder ones. In some places, stone columns spear the sky. In others, perfect arches frame it. Monument Valley in the United States. Utah's arches and the Sahara pinnacles are all products of that patient work. A breeze on your skin may feel gentle, but given time, it can sculpt landscapes like an artist, not with chisels, but with invisible currents pushing grains across stone. Lightning can turn sand into glass. When lightning strikes sandy ground, its intense heat melts quartz grains into glass. The strike fuses the sand into hollow branching structures called fulgurites, lightning turned to stone. These fragile tubes can extend several feet underground, their surfaces rippled and glossy from melted minerals. Each one is a record of a single bolt of fiery signature burned into earth. Fulgurites are prized by collectors and geologists, natural sculptures born in the heart of violent energy. Holding one is like holding a fossil of lightning, proof that the sky can remake rock in an instant. Glaciers flow like rivers of ice, reshaping continents. To the eye, glaciers may look still, but they are always moving from centimeters to meters per day. Over centuries, that slow, steady motion sculpts the land on a grand scale, grinding mountains into U-shaped valleys, dragging boulders for miles, polishing rock into smooth plains. During the last ice age, ice covered much of North America and Europe, reshaping entire continents as it advanced and retreated. Today, remnants persist in Greenland, Antarctica, and high mountain ranges continuing to mold the terrain. Stand near a glacier, and you feel the weight of time, a river, not of water, but of solid ice flowing with quiet persistence. Glaciers are living landscapes, slow, unstoppable, ever-changing whispering of ancient winters, and the power of weather frozen into motion. Avalanches can move faster than traffic on the highway. High in snowy mountains, a delicate balance holds between slope and snowpack. When that balance breaks, an avalanche begins a small slide, accelerates, gathering snow, ice, and debris into a thundering torrent. Speeds can exceed 80 miles per hour, faster than cars on the freeway, with crushing force enough to sweep away forests, homes, and roads. Its sound is like thunder rolling down a mountainside. Once started, it cannot be stopped. For skiers and climbers, avalanches are a constant hazard triggered by weather loading or a single step. But they are also part of the mountain's natural cycle, redistributing snow-shaping slopes and nourishing the valleys below. Watching one from a safe place is to witness nature's sudden fury, a reminder that snow is not always gentle. It can become a devastating flood in an instant. Icebergs hide nearly 90% of their mass underwater. The tip of the iceberg comes from a striking truth. Most of what we see is only a small fraction of what lies beneath. When ice breaks off glaciers or ice shelves and drifts at sea, most of its volume sits below the surface, often only about 10% shows above. That invisibility makes icebergs dangerous to ships. The Titanic tragedy is proof. Some are small, others are colossal, taller than skyscrapers and miles long. As they drift, they release fresh water into the ocean, quietly nudging currents and ecosystems. To imagine a giant block moving silently, mostly unseen, stirs the mind. Icebergs are monuments of frozen time, slowly dissolving into the sea, their true size known mostly to the deep ocean itself. Permafrost locks away ancient life. In the frozen soils of the Arctic and Siberia lies permafrost ground that has remained frozen for thousands of years. Trapped within are seeds, microorganisms, and even the remains of extinct creatures like mammoths. As long as permafrost stays frozen, these relics are preserved as if sealed in Earth's freezer. But when it thaws, ancient secrets awaken. Scientists have revived seeds tens of thousands of years old and even microbes that slept for millennia. Thawing permafrost also releases methane and carbon dioxide gases that can influence the global climate. To touch permafrost is to touch time itself, a soil layer that bridges the living present and the frozen past. Beneath your feet may lie not only ice and earth, but echoes of lost worlds silent until weather and warmth decide to release them. Meltwater from glaciers can create roaring rivers beneath the ice. Although a glacier appears solid, its interior is riddled with hidden rivers. When the sun warms the surface, meltwater seeps into crevasses and tunnels, plunging deep into the ice. There it gathers into thundering flows that carve channels beneath the glacier, echoing like underground thunder. These rivers can be strong enough to lift the glacier slightly off the ground, lubricating its movement. Sometimes meltwater bursts out suddenly from below, flooding valleys, a phenomenon called a Jokulhlaup, a glacial outburst flood. To walk on a glacier unaware of the raging water just beneath is to stand on a living system that breathes where water and ice are in constant dialogue. Those hidden rivers remind us that a glacier is not an inert block of ice, but a dynamic landscape alive with the pulse of weather and the veins of groundwater beneath its frozen surface. Weather guides animal migrations across continents. All over the world, animals move with the weather. Birds chase the sun's warmth. Whales follow shifting seas, and reindeer cross the tundra with the turning seasons. These migrations are among nature's grandest spectacles, and weather is the invisible compass. Winds carry monarch butterflies for thousands of miles. Currents steer fish schools, and rainfall patterns decide where herds can graze. A small change in the weather can bend ancient routes. To track a migration is to watch weather translated into movement storms, winds and rain woven into the instincts of life. Without cyclical weather, the great migrations would not exist, and countless species would lose their way. Each journey is a moving story written in the sky, where the heavens lead the travelers of land, sea, and cloud. Monarch butterflies follow the weather for thousands of miles. Every fall, millions of monarchs undertake one of the longest insect migrations on Earth, flying up to 3,000 miles from Canada and the northern United States to forests in central Mexico. Delicate wings carry them over plains and mountains, even across the Gulf of Mexico, guided by the sun magnetism and weather. They ride tailwinds when they can, to save energy and take shelter when storms rage too fiercely. Multiple generations complete the cycle, each one inheriting the journey from ancestors that never return. Weather along the way determines success or failure. A powerful storm can devastate the population, while favorable winds carry them farther. These fragile creatures cross a continent lifted and tested by weather, a spectacular reminder that the atmosphere connects all life. Birds ride invisible rivers of rising, warm air. High above fields and forests, birds often circle without flapping, turning smoothly as if hanging on invisible currents, the thermals that form when the sun heats the ground unevenly. Hawks, storks, and vultures use them to travel great distances with little effort. By hopping from one thermal to the next, they can glide for hours, saving energy for long migrations. From the ground, those lazy circles look effortless, but in truth they are navigating by an invisible weather map. Glider pilots use the same thermals, quietly flying alongside birds. Thermals remind us that the atmosphere is not empty space, but a living landscape of rising and sinking air. For those who can sense it, bird or human, these invisible rivers become sky pathways. Locust swarms are driven by rainfall. For centuries, locust swarms have been feared for their ability to strip landscapes bare in hours. These armies of insects can number in the billions, stretching for miles and darkening the sky. What triggers them is closely tied to the weather. Locusts boom after rains, turn deserts into green fields. When food is abundant, populations explode and shift into a swarming phase. Winds and storms carry them across continents, sometimes hundreds of miles a day. Ancient chronicles described locust swarms as the wrath of the gods. Now we know they are the offspring of weather born from cycles of drought and rain. To stand in a swarm's path is to see the atmosphere's influence made visible through countless wings. Each insect is tiny, but together, under the weather's guidance, they become one of nature's most formidable forces. Coral reefs bleach when the ocean is too warm. Coral reefs are among Earth's most dazzling ecosystems, home to countless species, yet they are fragile. Corals live in partnership with zooxanthellae algae, which provide food and color. When water becomes too warm, corals become stressed and expel the algae, turning ghostly white, a process called bleaching. Without their partners, corals can starve, leaving lifeless skeletons where vibrant cities once thrived. Bleaching events have increased in recent decades, threatening reefs across the tropics. From space satellites, see vast pale patches spreading across the seas. But corals are also resilient. When conditions improve, they sometimes recover over years. Watching a reef bleach is like seeing a living rainbow turn to bone, a reminder that weather and climate are intertwined with the health of even the ocean's smallest creatures. Shifts in weather have ended entire civilizations. History is often told through kings and wars, but weather has quietly shaped it from the start. Long droughts dried up the rivers that fed cities. Floods swallowed farmlands. A changing monsoon rhythm brought hunger to empires. Archaeological evidence shows that civilizations from the Akkadian Empire in Mesopotamia to the great cities of the Indus Valley collapsed after abrupt climate shifts. Harvests failed, trade routes withered, and people were forced to abandon homes built over centuries. Weather does not always destroy with storms or fire. Sometimes it unravels society slowly, like a thread pulled from a tapestry. In ruined temples and abandoned cities, we often see the fingerprints of climate. The rise and fall of civilizations is not only a story of human ambition, it is also a story of a sky that gives or withholds, of shifting winds and rains that never came. A single drought may have brought down the Maya Empire. Deep in Central America's jungles, the ancient Maya built towering cities, tracked the stars, and carved their history into stone. By the 9th century, many major cities were abandoned. The cause is debated, and one of the strongest clues comes from the weather. Sediment cores and cave stalagmites point to a decades-long drought with sharply reduced rainfall. Without water, crops failed, conflict rose and populations fell. Great pyramids and ball courts fell silent, swallowed by the forest. The Maya people endured, but the empire fractured and changed forever. To think that shifts in weather, invisible winds, and missing rain could topple a powerful culture is humbling. It reminds us that human history is not separate from climate, and even the mightiest city depends on the sky. Ancient battles were won and lost by storms. The outcome of wars has rested not only on strategy, but also on weather. In 1588, Spain's invincible armada sailed to invade England and was smashed by North Atlantic storms. Centuries earlier, Kublai Khan's fleets twice tried to invade Japan and were destroyed by typhoons the Japanese called kamikaze divine winds. More recently, mud, rain, and snow have bogged down armies and derailed campaigns again and again. Napoleon's retreat from Russia became a catastrophe under brutal winter conditions, while the D-Day landings in World War II succeeded because meteorologists found a rare window of favorable weather. Storms take no side, yet they have redirected history and decided nations' fates in an instant. In the chaos of battle, the sky is sometimes the most powerful commander. The Little Ice Age once froze rivers through the heart of Europe. From the 14th to the 19th century, Earth experienced a period known as the Little Ice Age. Winters were longer and harsher, glaciers advanced, and harvests struggled in the cold. In Europe, the River Thames in London froze solid multiple times, thick enough to host festivals on the ice. Paintings from the era depict frost fairs with tents, markets, and even ice skating on the river. In the Netherlands, canals froze so often that skating became part of the culture. Though not a true ice age, the period was cold enough to leave its mark on art, cuisine, and history. Volcanoes, solar variability, and shifting ocean currents all contributed to centuries of chill. To imagine great rivers turned into ice avenues shows how even modest shifts in climate ripple through human life. Cities create heat islands that are hotter than the countryside. Stepping from a shady park into a downtown core on a summer afternoon can feel like entering a hotter world. Cities absorb and retain heat more effectively than natural landscapes, a phenomenon scientists call the urban heat island. Asphalt, concrete, and steel soak up the sun's energy by day and release it slowly by night, keeping temperatures several degrees higher than nearby rural areas. Skyscrapers block wind, air conditioners exhaust hot air, and vehicle emissions add to the effect. Heat islands make heat waves more dangerous, especially at night when there is little cooling relief. There are solutions: planting trees, whitening roofs, and adding green space all help. Even so, the phenomenon shows how human design reshapes weather at the local scale. A city is like its own climate, a man-made heat oasis glowing against a cooler countryside. Skyscrapers can bend and accelerate local winds. Stand at the base of a tall building, and you may feel the wind suddenly whip. This comes from the way tall structures redirect AI. When wind hits a glass and steel wall, it is forced downward and around the building, creating gusts far stronger than in open areas. In some cities, winds can be strong enough to topple bicycles, flip umbrellas, and make walking difficult. Architects now use curved forms or cutouts to soften urban wind flows. Yet these street-side gales remain a vivid example of how human structures interact with weather. From the tops of skyscrapers, the wind can be smooth and even, but at street level, the air may churn with unexpected violence. The skyline is not just a backdrop. It reshapes the atmosphere itself, bending the invisible flow of air into new patterns. Air pollution can make sunsets blaze. Sunsets are always beautiful, but at times they flare with nearly surreal intensity. Vivid orange, deep red, and purple bands stretched across the horizon. That spectacle can be caused by tiny particles in the air. Dust, smoke, or pollution scatter the shorter wavelengths, leaving deep oranges and reds to reach our eyes. After major volcanic eruptions, sunsets around the world have been described as fiery and surreal skies, seemingly painted by ash suspended in the stratosphere. Though pollution harms health, it also shows how just small changes in the atmosphere can transform the sky's canvas. Every sunset is a collaboration between light and air, painted by invisible motes above us. When you see a crimson horizon, you're not just looking at sunlight, you're seeing the hidden fingerprints of weather and atmosphere pressed into the light. Clouds can be seeded to make rain. In some thirsty places, people have tried to coax clouds into releasing rain. The process, called cloud seeding, disperses particles like silver iodide or dry ice into the sky. These particles act as condensation nuclei that water vapor can cling to, helping droplets grow large enough to fall as rain. Cloud seeding has been tested since the mid-20th century, with mixed results, sometimes modestly increasing rainfall. Airplanes, rockets, or even ground-based equipment release particles into the air, turning weather into a field experiment. While not a magic wand, cloud seeding has been used in China, the United States, the UAE, and elsewhere. The idea that humans can nudge clouds into raining is a striking reminder of how we interact with weather, a kind of atmospheric alchemy harnessed by science when needed. A red sky at sunset often does foretell tomorrow's weather. Red sky at night, sailors delight. Red sky in morning, sailors take warning. This old proverb has real atmospheric roots. At sunset, a red sky often means dry, dusty air to the west, where weather systems typically approach from hinting at stable conditions and clearing skies ahead. Conversely, a red sky at dawn can indicate that a dry layer has passed, leaving unsettled weather behind it. The scattering of light through dust and moisture paints the sky in red tones, a visible sign of the atmosphere's state. Before satellites and forecasts, sailors, farmers, and herders relied on signs like these to plan their days. While not perfect, the rhyme carries knowledge distilled over centuries. The colors of sunrise and sunset are not only beautiful, they are messages from the sky, ancient forecasts written in light. A rainbow is a circle we usually see only the top half from the ground. A rainbow appears as a soft arch, but in reality, it's a full circle of light. We see only the upper half because the horizon hides the rest. Pilots sometimes report seeing complete circles when looking down on storms from above. Every rainbow forms when sunlight enters a raindrop, refracts inside the drop, then refracts again on the way out. This bending separates the light into its spectrum, fanning into a bright ring. The size of the circle depends on the sun's angle, but the ring is always whole. Knowing we see just a portion of the complete circle makes a rainbow feel even more wondrous. What looks like an arch overhead is actually a full wheel of color. Double rainbows reveal light's hidden pathways. Sometimes, if conditions are just right, a rainbow is accompanied by a fainter sibling above it. A double rainbow occurs when light reflects twice inside the raindrop instead of once, sending light back at a different angle and creating the outer arc. In this secondary bow, the colors are reversed: red on the inner edge, violet on the outer. The darker gap between the two arcs, called Alexander's band, looks dimmer because less light reaches it. Double rainbows aren't rare, but they always feel magical, two bands of color layered across the sky. Poets and painters have praised them for centuries, while scientists see a refined optical performance. Each rainbow is a marvel. When there are two, it's as if the sky opens secret tiers of light, doubling the beauty of the glow after rain. Sundogs sparkle like extra suns on cold days. On very cold days, when ice crystals drift high in the atmosphere, strange companions can appear beside the sun. These are sundogs, glittering spots on either side of the sun like phantom stars. They form when light refracts through hexagonal ice crystals in cirrus clouds, splitting into colors like a rainbow. Sometimes they are just faint smudges. Other times they blaze, creating the illusion of three suns shining at once. Sundogs are easiest to see when the sun is low near the horizon, often at winter sunrise or sunset. To earlier people, they were omens, signs of power or mystery in the heavens. To us, they're a dazzling show of how ordinary sunlight interacts with the atmosphere's frozen breath. Seeing a sundog is catching a glimpse of the hidden art of sunlight painting the cold sky. Halos appear when light bends through ice crystal clouds. Look up on a frigid day and you may see a luminous ring around the sun or moon. This is a halo formed when light passes through countless tiny ice crystals in thin, high clouds. The crystals bend rays at precise angles, creating a glowing circle around the bright object. Halos often herald an approaching weather front because the cirrus clouds that make them are early signs of change. They can shimmer white or carry a faint rainbow fringe. Moon halos are especially enchanting, pale rings drifting on a dark canvas. These simple shapes arise from myriad silent crystals, each bending light in the same way. A halo is both a forecast and a piece of sky-born geometry, a tranquil message from the atmosphere etched in light. Mirages can conjure lakes where none exist. On hot summer days, a traveler in the desert or a driver on a long highway might glimpse shimmering pools at the horizon. Move closer, and the water vanishes a mirage. This illusion happens when layers of hot air near the ground bend light upward. Instead of traveling straight to your eyes, light from the sky is curved, creating the impression of reflective water ahead. These optical tricks are so convincing that wanderers once chased them, finding only more sand. Today, mirages still fool us into seeing floating ships, distant lakes, or warped road surfaces. They remind us that what we see isn't always reality, but sometimes the atmosphere plays with light. In a wavering instant, a mirage blends physics and art into scenes that fade as quickly as they appear. Superior mirages can make ships look like they sail the sky. In polar regions and over cold seas, another kind of mirage appears stranger still, called a superior mirage. It occurs when layers of cold and warm air bend light downward, making distant objects appear higher than they are. Ships beyond the horizon can seem to hang in midair. Castles may float above the waves and coastlines look stretched or doubled. Long ago, sailors told of ghost fleets suspended in the sky masts, reaching into the heavens. The bending can create forms so surreal that it may have inspired legends of phantom lands, though the explanation is scientific. The effect is no less enchanting. Superior mirages remind us that the atmosphere is a lens constantly shaping what we see, turning the ordinary into the extraordinary. The ship seems to sail not on water, but across the sky. The green flash lasts only a few seconds at sunset. At the instant the sun slips below the horizon, some lucky observers may catch a brief emerald flare, the green flash. This rare phenomenon occurs because the atmosphere disperses sunlight into its spectrum. Blue and violet are scattered away, red passes through. Just enough green remains to flare a moment before the sun vanishes. It lasts only seconds and requires a careful eye, usually offshore where the horizon is clear. For centuries, sailors and poets saw it as a sign of luck or mystery. Science now understands the optics, but the wonder remains. Seeing the green flash is witnessing a secret of the sky, the final accent hidden in the fading stripe of sunset. Few have seen it, but those who have rarely forget that sudden green fire. Moonbows glow faintly under a full moon. Rainbows usually follow rain, but under a full moon, a similar effect appears in a dimmer form. A moonbow is a pale arch formed when moonlight is refracted through raindrops at night. Because moonlight is so much weaker than sunlight, a moonbow often looks white to the naked eye, its colors too faint to distinguish. Long exposure photographs can reveal their soft spectrum. Seeing a moonbow is rare. Conditions must be perfect with rain in one part of the sky, and a bright full moon low on the opposite horizon. In folklore, moonbows are considered magical glowing bridges in the night. They are among the weather's most delicate spectacles, a quiet echo of the rainbow that feels more dream than reality. A bow not painted by the sun, but by the moon's silver light. Lightning can strike the same place more than a dozen times. The common saying claims lightning never strikes the same place twice, but the truth is the opposite. Lightning favors tall, conductive objects and returns to them again and again. New York's Empire State Building is struck about 25 times each year. TV towers, mountaintops, and even solitary trees in fields can be hit repeatedly during a single storm. That's because such objects act as guides, making it easier for charge to discharge from sky to ground. Lightning isn't pure chaos. It follows physical rules, finding paths of least resistance. Understanding this helps engineers design lightning rods to protect structures by inviting strikes to safe points. So even though lightning seems erratic, it is strangely loyal, returning to familiar targets, repeatedly leaving a fiery signature in the same spot. Ball lightning has been seen glowing inside an airplane cabin. Among the most mysterious weather phenomena is ball lightning glowing spheres that sometimes appear during thunderstorms. Witnesses describe bright orbs from a few centimeters to a few meters across shining white, yellow, or even blue. They drift slowly, sometimes pausing, sometimes darting, and often vanish with a pop or hiss. One startling report comes from a 1960s flight where passengers saw a glowing ball float down the aisle before disappearing. Science still does not fully understand ball lightning, plasma, burning vapor, or something else. It is so rare that many scientists once doubted its existence. But too many accounts from pilots, sailors, and storm chasers confirm it is real. Ball lightning remains one of the atmosphere's great riddles, a ghost flame that wanders and winks out, returning the sky to the storm. Sprites flash red high above thunderstorms. Most lightning bolts strike downward between storm clouds and the ground. But high above cloud tops, strange fleeting flashes sometimes appear sprites. These enormous red structures reach into the upper atmosphere like phantom jellyfish. They occur when powerful discharges disturb the electric field, sending energy upward instead of down. Sprites can span tens of miles, but last only milliseconds, too quick for most eyes to catch. Pilots at cruising altitude sometimes glimpse them dancing above distant storms, and modern cameras have captured their eerie beauty. Sprites remind us that a thunderstorm is not confined to the clouds we see. It stretches up toward the edge of space, sketching the thin air with burning red strokes. A storm that glows both below and above reveals just how alive the sky truly is. Blue jets launch bolts toward space. While sprites burn red, their cousins blue jets shoot in the opposite direction, firing from storm tops into the stratosphere. They appear as narrow electric blue cones thrusting toward the edge of space. Though rare and hard to study, astronauts aboard the International Space Station have seen them firsthand, describing glowing spears rising from storms below. Scientists think blue jets occur when charge builds at the top of a storm and discharges into the thin air above. Unlike ordinary lightning that strikes the ground, blue jets are the sky's escape route upward. They show that storms are not isolated, but part of a larger atmospheric circuit stretching from the ground up to the heavens. To imagine lightning reaching for the stars instead of the earth is to glimpse the hidden path of electricity in the highest layers of air. Volcanoes can unleash their own electrical storms. When a volcano erupts, The ground roars and lava ash and smoke surge into the sky. But within that ash cloud, something stranger happens: volcanic lightning. As ash particles collide and rub together, they build charge, much like ice crystals in a thunderstorm. Bolts rip through the dark plume, tearing open the night. These storms can be so intense that the whole sky pulses with electricity, casting an eerie light over the land. Witnesses describe an apocalyptic scene: fire below, riven sky above. Scientists study these tempests to learn more about how lightning forms. For those who see them, no explanation is needed to feel awe. Volcanic lightning is nature's double storm: fire and electricity in tandem, a reminder that Earth's weather is no less fierce than the forces below. The strongest storm ever measured happened right here on Earth. Even though other planets host colossal tempests, Earth has spawned terrifying winds of its own. The title of the most intense tropical cyclone belongs to Super Typhoon Tip in 1979. At its peak, it sprawled over 1,300 miles, nearly half the width of the United States. Its central pressure fell to a record low, signaling ferocious strength. Winds screamed over 190 mph, and rains flooded vast regions. From satellite tip, looked like a perfect spiral, a gigantic pinwheel covering the western Pacific. Though it weakened before landfall, its size and power remain unmatched. To contemplate a storm large enough to blanket a continent humbles us. Even on a world we think we know, the atmosphere can still summon unimaginable fury. Jupiter's Great Red Spot has raged for centuries. Through a telescope, a huge oval churns in the southern hemisphere, a storm larger than Earth, spinning for at least 300 years, perhaps longer. Winds exceed 400 mph, stirring ammonia clouds into beige and red bands. Unlike tropical cyclones on Earth, which fade in a few days to weeks, the red spot endures, sustained by Jupiter's immense atmosphere and energy. It changes over time, shrinking, shifting in color, yet still spins an emblem of planetary fury. Astronomers track it like a living being, a storm that has outlived many generations of observers. Saturn's hexagon rotates perfectly around its pole. This planet hosts one of the strangest weather phenomena in the solar system: a giant six-sided storm encircling the North Pole. The hexagon is larger than Earth, a jet stream that's somehow locked into a precise geometry. Discovered by Voyager in the 1980s, it has persisted for decades, turning like a kaleidoscope in the stars. Scientists think wind speed differences create a standing wave in the atmosphere, carving the storm into that odd polygon. From above, the shape looks hand-drawn by a cosmic artist rather than made by nature. Uranus has winds faster than the speed of sound on Earth. Distant and seemingly quiet, this planet actually harbors jet streams, racing around at up to 200 miles per hour, faster than Earth's speed of sound. Those winds lash through an atmosphere of hydrogen, helium, and methane, sculpting faint cloud bands. Why it winds up so violently is still unclear. Its tilted axis, unusual interior, and far-flung orbit likely play roles. From afar, it appears calm, but up close, it's a world of supersonic winds, silent tempests on an icy giant, reminding us appearances can deceive. A planet that looks peaceful can still roar. Neptune's dark storms are supersonic superstorms. The farthest planet from the Sun hosts some of the most violent weather in the solar system. In 1989, Voyager 2 captured a great dark spot, swirling through its atmosphere, a hurricane-like storm with winds up to 300 miles per hour, the fastest on any planet. These tempests can span thousands of miles, persist for years, then vanish and reappear elsewhere. The frigid methane-rich air paints storms deep blue and shadowed. Though remote, these systems feel alive, changing intense, even under the faint sunlight at the solar system's edge. To imagine standing amid winds faster than bullets is to brush against weather in its most extreme, alien, and wild form. Some exoplanets have sideways blown glass rain. Among the thousands of exoplanets discovered, some worlds defy imagination. On one distant planet, the sky is filled with silicate particles, tiny shards of glass. Winds howl over 4,000 miles per hour, strong enough to hurl those grains sideways through the air. The result is a storm unlike anything on Earth, glass, rain blown sideways at supersonic speed. Based on the stars dimming as the planet passes in front, the data suggest an environment both beautiful and deadly with brilliantly reflective blue clouds. Compared to that, Earth's fiercest storms seem tame. Exoplanets remind us our weather is just one dialect in a vast language spoken under countless skies. Elsewhere, clouds are made of molten iron. On worlds that orbit very close to their stars, temperatures exceed 2,000 degrees. Clouds don't form from water vapor, but from metal vapors like iron. When conditions change, iron condenses and falls as metallic rain. Picture droplets of red-hot iron hissing as they hit the ground, flaring, then cooling into solid metal. Uninhabitable as they are, such realms stretch our notion of weather. Earth's familiar, evaporate condense cycle is only one dialect in the universal grammar of the sky. Earth's atmosphere once glowed orange after it formed. Billions of years ago, the young air was rich in volcanic gases, carbon dioxide, methane, ammonia, and nitrogen. With no oxygen, the sky was a dim orange under a weak sun bathing the surface in alien light. The seas fizzed with chemical reactions, and the earliest life began under that strange canopy. Over time, photosynthetic microbes released oxygen, slowly transforming the atmosphere. The haze thinned. The sky turned blue, and the ozone layer formed, shielding life from harmful radiation. To picture Earth beneath an orange sky is to glimpse a planet in transition, before green forests, teeming seas, and the clouds we know. Our atmosphere has never been as unchanging as it feels today. It has transformed dramatically, carrying the story of life itself. Ancient ice holds tiny samples of prehistoric air. Deep within glaciers and ice sheets, bubbles of air are trapped, sealed for tens of thousands of years. When scientists drill ice cores in Antarctica or Greenland, they're not just collecting frozen water, they're retrieving time capsules. Each layer of ice records the atmosphere from the year it formed. Inside those bubbles lies the air our ancestors once breathed, preserved across millennia. From these ancient samples, Earth's climate history is reconstructed shifts in carbon dioxide, oxygen, and methane over hundreds of thousands of years. Cycles of ice ages and warming, the intimate dance between climate and life. Holding a fragment of ancient ice is cradling Earth's breath from long ago, a whisper of prehistoric skies kept in crystal. The carbon cycle is tightly tied to weather. Every breath we take, Every storm that falls, every passing gust, relates to carbon's journey through air, land, ocean, and life. Plants draw in carbon dioxide, locking it into leaves and wood. Animals eat, respire, and return it. The oceans absorb vast amounts, storing it in shells, sediments, and deep waters. Volcanoes release carbon while rock weathering slowly draws it down again. Weather is both driver and messenger. Rain washes carbon into rivers, storms churn it into the sea, and seasonal winds decide how much carbon plants breathe in. The carbon balance sets Earth's temperature and climate, the planet's pulse. Clouds both warm and cool the Earth. By day, they reflect sunlight back to space, cooling the surface. By night, they hold in heat like a blanket, slowing the escape of warmth. The balance between these effects decides whether clouds warm or cool a region. And at the global scale, scientists are still tallying which dominates. Different cloud types play different roles. Low, bright clouds tend to cool, while thin, high cirrus trap heat efficiently. Without clouds, Earth would be much hotter by day and much colder by night. The clouds drifting above are more than water vapor. They're temperature gatekeepers, the soft shields constantly shifting over our heads. Melting sea ice alters winds and ocean currents. In the Arctic Sea, ice is a bright cap that reflects sunlight. As the climate warms and ice melts, darker water is exposed, absorbing more heat. That change ripples outward, disrupting winds, currents, and even weather patterns far away. With less ice, the atmosphere shifts, sometimes pushing Arctic cold far south in winter, or altering precipitation elsewhere. The loss also breaks ecosystems, affecting polar bears, seals, and others that depend on ice. The yearly rhythm growth and melt is a crucial gear in the climate machine. Watching it retreat is like seeing a gear slow down, forcing the whole system to run differently. Climate change is making extreme weather more common. Globally, the trend is clear. Extremes are becoming more frequent and intense. Heat waves last longer. Wildfires spread farther, storms grow stronger, and floods hit harder. A warmer atmosphere loads the dice, making certain events more likely. Warmer air holds more moisture, fueling heavy rain. Warmer seas feed tropical cyclones. These shifts reach into agriculture, health, and safety, underscoring how climate and weather intertwine. What happens in the sky is linked to choices we make on the ground. Understanding that link helps us prepare, adapt, and reduce risks. Extreme weather isn't only a natural force anymore, it increasingly bears a human fingerprint. Storm surge is rising along with the sea. When hurricanes or cyclones make landfall, the deadliest threat isn't just wind, it's the wall of seawater the storm shoves ashore. Those walls can climb meters high, drowning coastal cities and sweeping away homes. As sea level rises in a warming climate, storm surge starts from a higher baseline, making it more destructive. Places that rarely flooded may now face it regularly. From above, the surge looks like the ocean rising up against the land, erasing the shore. For people near coasts, it's where climate and weather meet most plainly, the atmosphere's power translated into the sea's language, slamming into human shores with unstoppable force. Heat waves are getting hotter and longer. Heat has always been part of weather cycles, but in recent decades, heat waves have grown harsher. Records are broken not by a degree or two, but by margins once thought unlikely. Nights, once a refuge, now stay sweltering, locking heat into cities. Crops wither, reservoirs drop, and power grids strain as people seek cooling. Heat waves kill more people than any other kind of extreme weather. Their impact is quiet but devastating, tied to a warming climate that shifts the baseline higher and makes extremes easier to reach. For those living through them, heat waves prove that weather isn't always thunder and downpours. Sometimes it's a stagnant, suffocating air mass seeping into every corner. And increasingly, those waves are defining summer worldwide. Rainfall is redrawing the global rules. The rhythm of rain shapes life. Monsoons, seasonal storms, and steady showers nourish crops, forests, and rivers. But as the climate changes, these patterns are shifting. Some places see more torrential rains, others endure longer droughts. Storm tracks wobble dry zones, expand, and once fertile regions grow parched. For communities that rely on scheduled rains, these changes bring uncertainty and struggle. Satellites now watch global rainfall, showing humid belts on the move, reshaping entire swaths of land. It's as if the planet is redrawing its wet-dry map. Air still holds water, clouds still form, but where and when they drop their gifts from the sky is changing. This global redistribution of rain is a quiet revolution in weather, rerouting rivers, widening deserts, and tilting the balance of life. Lightning may increase as the climate warms. Thunderstorms are fed by heat and moisture, and as the world warms, both ingredients grow. Some research suggests this could mean more frequent lightning in the coming decades. More lightning can mean more wildfires, more ozone formed in the atmosphere, and greater danger to people and animals. Satellites already track millions of strikes each year, mapping their shifts. Though forecasting remains complex, the link between warming and lightning is a vivid reminder that small temperature changes can ripple into storm behavior. Each bolt is an instant release of energy born from the atmosphere's restless churn. As Earth heats up, those sparks may multiply, lighting the sky with more of nature's electric fire than ever. Future tropical cyclones are projected to be stronger. As oceans, warm storms draw extra fuel from the heat stored in water. A once moderate cyclone can grow into a monster. Winds intensify, rains grow more torrential, and surge pushes higher ashore. Scientists already see a trend: fewer storms overall, but more of them reaching Category 4 and 5. From space, satellites record vast, mesmerizing spirals, while on the ground, people face jet engine winds and seawater walls. The storms of the future won't just be natural events. They'll be stories of resilience, adaptation, and preparedness. Thinking about the superstorms to come is both sobering and motivating. The atmosphere is sharpening its blade as it reflects the heat we've added to the planet. They remind us weather is lively, restless, and always ready to show its full force. Floods and droughts may alternate more often. Around the world, many are noticing a new rhythm: long dry spells followed by deluges. This alternating pattern connects to a warmer atmosphere that can hold more moisture. Dry periods get drier while storms dump more water in less time, overwhelming rivers and soils. A growing season can be both thirsty and flooded in the same year. These swings can recut landscapes, reroute rivers, and leave cracked fields behind. Witnessing the contrast is seeing the atmosphere pull harder at both ends of the spectrum. Flood and drought have always been part of weather cycles, but now they arrive more fiercely often in the same region, even the same year. It's as if the sky hesitates sometimes, giving nothing, sometimes giving everything at once. Satellites now blanket the entire planet. High above Earth, a silent fleet orbits watching the air. They track cloud motions, measure temperatures, scan humidity, and even peer into storms' hearts. Every few minutes they beam torrents of data home where scientists weave forecasts. From these sentinels, no corner is missed. Cyclones spinning over oceans, dust storms sweeping deserts. Even the faint uptick in water vapor before a storm forms. These satellites have transformed forecasting, giving us days of lead time and saving countless lives. They also grant beauty weather imagery of Earth as living mosaics of color and motion. Knowing those machines keep watch above, turning the atmosphere's chaos into patterns we can study, shows how far we've come in learning the sky's language. Supercomputers can simulate storms days before they form. In vast rooms cooled by roaring fans, supercomputers hum like colossal brains performing billions of calculations per second. With that power, scientists feed in satellite data, sea surface temperatures, and atmospheric conditions to model the weather. These models can spin up simulated storms over the ocean a few days before they even exist, forecasting their paths, intensity, and rainfall. Each model run is like a dress rehearsal for the future, where the atmosphere performs its possible moves. Though not perfect, these simulations are astonishingly powerful, buying communities extra time to prepare for hurricanes or heat waves that once struck without warning. It's a kind of time travel, a glimpse of tomorrow's weather using today's math. To think that invisible equations crunched at lightning speed can whisper what clouds, wind, and rain are about to decide is enough to leave us in awe at how science can dream with the sky. Today's forecasts are more accurate than at any time in history. Not long ago, predicting the weather was little more than instinct. Farmers leaned on sayings, sailors read the color of the sky, city dwellers felt the air. Now forecasts are astonishingly precise. We track storms across oceans, predict rain down to the hour, even issue tornado warnings minutes before they touch down. What once felt like fortune-telling now rests on physics, satellites, and models digesting billions of data points. Even if we grumble when a shower ruins a picnic, it's worth remembering the miracle we can know the atmosphere's mood days in advance. Forecasting is a collaboration between people and the sky, imperfect, yes, but profoundly more accurate than at any point in history. In it, we see how far our understanding of weather has come and how much farther it can go. And yet, the chaotic nature of weather makes perfect prediction impossible. Even with satellite supercomputers and models, the sky remains a master of surprise. The atmosphere is a chaotic system exquisitely sensitive to the tiniest changes. A shift in wind direction, a warm patch of sea, or a sudden convective plume can alter a storm track, ripple through rainfall patterns, or scatter clouds in unexpected ways. That sensitivity makes long-range forecasting hard. Beyond a week or two, the atmosphere veers into uncertainty as countless small variables compound. People sometimes call this the butterfly effect, the idea that even a single wing beat could tip the balance of the weather. This unpredictability isn't a bug, it's nature's truth. The sky keeps secrets we may never fully solve. Knowing that lets us receive weather not only as science, but as wonder. a reminder that some of Earth's rhythms will always keep their mysteries. Animals often sense storms before humans do. Long before meteorology, animals listen to the sky in ways we can scarcely imagine. Birds may flee an area before a storm, sensing pressure changes or distant thunder's low rumble. Cattle and horses sometimes grow restless as the air feels heavy, while dogs and cats hide away their ears, tuned to sounds we can't hear. Insects respond too. Bees hurry home, ants seal their nests before rain. Science has measured that many species detect pressure changes far more keenly than we do. Farmers once relied on these subtle signs, reading their herds to guess how the sky was about to marshal its forces. Today, even with satellites sweeping the air, animals remain our oldest forecasters, instinctive, sensitive, tuned to the weather's whispers. Their alertness reminds us that forecasting isn't only high-tech, it's woven into life itself. Your joints may ache when pressure drops. Many people feel a dull ache in knees, shoulders, or hands before a storm, and it's not your imagination. Changes in atmospheric pressure, the weight of air pressing on us, can affect tissues in the body. As pressure falls ahead of a storm, fluid in the joints can shift, irritating sensitive nerves and inflamed areas. For those with arthritis, that can mean pain or stiffness, like having a built-in forecast inside the body. Not everyone is sensitive, but enough people are that doctors take it seriously. It seems the human body is a weather station of its own, registering shifts in the invisible atmosphere. It's striking that the same pressure changes, driving clouds and wind, can ring inside us when the sky is about to rain. Sometimes our bones know first, humming along with the approaching storm. The sky can turn green before a tornado forms. Before a severe storm unleashes, the sky sometimes glows an eerie green. This unsettling hue happens when sunlight filters through storm clouds, heavy with rain and hail scattering in a way that highlights green wavelengths. To meteorologists, it's a sign of a storm strong enough to produce hail and possibly tornadoes. To witnesses, a green sky feels like a surreal curtain stretched across the horizon, a cold hush before chaos drops. Even with the science in hand, the sight lingers. That green light is the weather's warning lamp, signaling that something violent is taking shape behind the clouds, ready to strike with sudden fury. Weather is Earth's heartbeat, always changing, never still. Beneath the blue dome, weather moves without end. Winds shift, clouds gather and dissolve, rain falls, and sunlight breaks through again. Every breeze, every drop, every glint of light belongs to a living system, restless and endlessly renewing itself. Looking up is feeling the planet's pulse, sometimes gentle, sometimes wild, but always present. Weather isn't just our backdrop, it's the rhythm that sustains oceans, forests, and fields, the force shaping civilization, the storyteller in rainbows, the whisper in a quiet snowfall. Calling it Earth's heartbeat isn't a metaphor so much as a map, the circulation of air and water, the flow of energy that keeps our world alive. And even as we measure, forecast, and simulate, we're still passengers beneath its endless song. Our journey beneath the sky draws to a close. We've drifted through tempests and soft sun, past clouds as heavy as mountains, and raindrops sculpted by invisible forces. We've wandered deserts where rain never falls, stepped into the freezing heart of glaciers, and looked up at strange halos, sprites, and sundogs. Together we've seen that weather isn't just the backdrop of our days, it's the living rhythm that shapes land, life, and history. Weather is ancient and always new. It toppled empires long before satellites, and it still surprises us now even with computers and forecasts. It whispers in a butterfly's wing, gleams in a rainbow, and roars in the voice of the gale. It is chaos and pattern, danger and beauty, a reminder that life is breathing beneath our feet and above our heads. Perhaps as you lie here, you picture the sky outside your window shifting in its own quiet way. Maybe a breeze is stirring the leaves or a cloud is sliding past the moon. Even in this stillness, the atmosphere never rests. It is the planet's vast breath circling on, carrying the seeds of tomorrow's storm and the peace of the coming dawn. As you drift towards sleep, let thoughts of the weather be a comfort. Its cycles remind us that change is natural, that after storms it clears, that nothing stays the same forever. The sky that once glowed orange over newborn Earth is shining over you tonight, steadfast, timeless, and full of wonder. Thank you for joining the Easy Sleep Science channel on this journey. If you enjoyed this gentle wander, I invite you to subscribe and come back again. Many more nights of science and storytelling are waiting for you here. For now, let the wind settle the clouds part and your thoughts grow light. Rest within the rhythm of the sky, inside the pause of Earth's heartbeat, grateful that you are part of this vast, ever-changing story. May your dreams drift like clouds on a soft wind. Good night.